Welcome to Building Evolutionary Architectures. Some words about us. I'm Xavier, I'm working for Murex. We build software for capital markets.
And I'm Balosin. I'm a software architect based in Bucharest, working for Luxoft.
Okay, now we want to hear a bit about you. Are there some architects in the room? Okay. Now, who is working in an agile environment? Good. Okay, now imagine that you're setting up a new project, a new team, and you have a limited budget, and you have to choose. You can hire an architect, or you can hire an agile coach. Which one do you choose? Who hires an architect? Okay, and who will hire the agile coach? Okay, and who will keep the money for other things, like beers? Okay, good. A small word about this book, Building Evolutionary Architectures. This book was released just a bit after we finished writing this presentation. We gave this presentation first in Netherlands 1 week before the book was released. However, we adapted the vocabulary, terminology, to the terminology that are in this book because I think that they will have a bit more audience than us. What we'll see today, first we will visit some misconceptions about agility, about architecture, that make people think that they might be in contradiction, okay? But then we will prove you that, at the contrary, agility and architecture design share a common goal of building evolutionary systems, and then we will see afterwards how they work together. So, time now to visit some misconceptions.
Okay, so the first misconception, and I would like to ask you, Xavier, about that because you are a convinced agilist, it's responding to change versus following a plan. And for me, from an architecture perspective, it seems a bit misleading because I like to have a plan, right? I don't want to live in a such volatile world. Everything is changing. How do you interpret that? What's your opinion on that?
So indeed, the Agile Manifesto says that you should embrace change over following a plan, but it doesn't mean that you don't have a plan at the beginning, right? It rather means that you have a plan, but you keep other options open, right? You should be able to take a shortcut if a shortcut appears. You should be able to change route if there is a block road, if there is a traffic jam in front of you. So it doesn't mean no plan. Mm-hmm. It means that in this fast-paced changing context, you should be able to stick a bit out of the plan and follow another route.
Okay, I got it.
Me, I have a concern with architecture. I heard that architecture is about designing upfront the things that are very hard or impossible to change afterwards. I have two problems. First of all, these days I don't think that there are things that can be that can be carved in stone and can never change. Everything is changing around us. The second problem I have is that I don't trust anyone to be right the first time, especially you after I've seen your tattoo.
Okay, so let me bring my thoughts around this. First of all, yes, indeed, the software world changed a lot. There is a lot of volatility. However, it's not about fixing a lot of things without being able to change them later on. A few decades ago, we lived in an era where the architects designed boxes and lines, very big upfront design, and due to the waterfall process, we need to follow on them. After that, we changed the things because the complexity in software increased a lot, so we decided to be more dynamically. In regards to that, of course, we shouldn't design big upfront anymore. We should design just enough, but we still need to design. However, the quantity of designing depends from project to project, from elicitation process. For entities, and all the things around. And more than that, of course, you can't follow on the same patterns, the same architectural principles and styles from one project to another unless you live in a very repetitive world. So the project's requests are the same, the prioritization is the same. But let me give you more on this. Let me first give you my understanding about what means the architecture. This is the shortest definition I could find, the important stuff, which belongs actually to Ralph Johnson. And I might understand you, you might be a bit puzzled. What's the important stuff in your application? The question is, how should I build the internal architecture, the design itself of the application from that important stuff? We live today in a world of entities. In all the projects there are entities, different entities, also a few of them particular to the domain. For example, you might prioritize or you might deal with extensibility, performance, security. All of these entities, as you can see, there is a world of them, and as an architect you need to choose. However, before deciding which is better than the other, you might be conscious about some divergences between them, because, for example, in your project, if you increase one, you might impact or degrade the other, as is the case for performance and security. Why? Because the security is implemented via tactics like encryption, and increasing security you might impact performance. The same might happen in case of performance and modifiability. Being the product more modifiable, which it's good because it brings flexibility, it brings extensibility. However, creating this loose coupling and the opportunity to add features easily may have an impact on performance. So that's why I was saying that we need to do the trade-offs. We live in a world of trade-offs in software architecture. So we can't gather all the utilities, prioritize, and implement all of them. So first, what's the idea? First of all, it's to listen to the stakeholder, listen to the customer, listen to the end user, and gather his opinion, what's important for the product. For example, I've put here the first category, which belongs to the stakeholder prioritization, which is availability, security, performance. All of these are coming from the business. And in few cases, the customer itself can name them. For example, any image anywhere in 1 second, or I want the product to be robust and solid. So this comes first from the customer. However, we should complement all of this with another set of quality attributes, which I call for this presentation vital. Why they are vital? Because they complement the first category, the ones which is elicited based on the customer or according to the customer, and they ensure the evolution for the first category in time. Because what might happen in the project, there are cases where the customer can't tell you, I want my product to be testable, I want my product to be flexible, right? But you as an architect should build in these entities inside the product. So that's why in the book that Xavier mentioned initially, there is another key ingredient. It is called evolvability, which basically protects both of these categories to survive in time. And linked to the initial definition, now I think it's more clear for you what architecture is and what is this important stuff which belongs to Ralph Johnson.
Okay. Clearly, I prefer this definition because it resonates a lot. Because for me, agility is not a thing; it's an ability. It's the ability to move quickly and easily, right? We are in a fast-paced, changing world, and in this world, we need to adapt very, very quickly. And if you have a look at the Agile Manifesto, the manifesto tackles organization, collaboration, planning, but of course, and before, software. And for software, the piece of agility which is important is the principles of extreme programming. And in extreme programming, the principles, maintainability, testability, simplicity, as you can see, they resonate with your previous definition and your previous principles of architecture. And clearly, software evolvability is also at the heart of agility. So I think that here we can clearly say that we are not in contradiction, architecture design and agility. And I propose that we can see that now how to work together. So in the next section, your note will tell you how to provide an architecture design that is truly agile. Then afterwards, I will tell you how agility can help in return the architecture design. And then we'll see what's next, what challenge is remaining.
Okay, let's see how it goes, actually. So I'd like to share with you a few anti-patterns that there are better chances to lead towards a non-agile architecture. So let's zoom inside each of them, and I'll explain one by one. First of all, the first big challenge is this big ball of mud. Since we are Java guys attending this conference, you might recognize this picture. It's basically a snapshot out of JDK 7 taken in 2009, basically before the modularization, the Jigsaw project to start. And as you can see, do you like this kind of dependencies? It's a spaghetti network. This is the big ball of mud. It creates a very, very tight coupling between all of these components. Changing one may impact all of them, and also releasing one. If you, for example, would have components, it needs to release all the others that rely on. The same might happen in case of microservices pattern, which is basically a good architecture style because it allows you to isolate the services to develop them independently. You can also outsource the work. However, if you don't use them consciously, you create this zoo of dependency. And also, for example, if you want to change the API of one, you will impact a lot of the others. Also, if you want to upgrade from one version to another, it's also a challenge. You can create also dependencies across services or components with the data itself. Be very careful when you design applications, because even if you rely on microservices architecture pattern, but those services could be coupled by data, because, for example, changing the data format across that flows across services, if you affect more services, you create a data coupling implicitly. So it's still not quite a good design. Also, if via shared packages or modules, if you rely from different components on modules on shared packages, you create implicit coupling as well, which is not a very good approach, especially for microservices or domain-driven design, because in such cases, for example, in microservices, it's better to duplicate than to share. However, keep in mind that it might impact, for example, changing the shared one implicitly impacts the others that relies on it. And also the transactions, especially if the transactions are distributed. For example, in our environment, on our project, we decided to cut as most as you can the XAT transactions. Why? Because, for example, as you can see on this diagram, one request that hits two services, two database under the hood, actually creates an implicit coupling. And even if you look at these two services in isolation, from an isolated perspective, you create coupling between those two. And still, it's not quite a flexible design. It adds rigidity. The next section, it's about the symptoms, because we saw here what would be some non-recommended ways or anti-patterns. Let's see what are the symptoms, because for the business perspective, from the business stakeholders, doesn't really care about internal design. Architecture, it's mainly about internal quality. But what are the visible qualities of such non-agile architecture? First of all, when you have features, for example, it's very difficult to incorporate incorporate new features. Why? Because the product is not flexible, is not modularized enough, it's not manageable. Or even if you can add such features, you create side effects, for example. Another symptom is if you have a very slowly recycles. For example, if you ask yourself, what is the latest, when happened the latest released version for my product? If the answer is several months ago, it's probably not very, very flexible, and you should work on modularization. You should work on small pieces to be easily deployed, easily manageable. Also for the customer, it's not good because the customer needs to wait several months in a row or maybe 1 year to wait for all of the features that are bundled together, and all of them are coming on the customer side. Plus, if something happens, for example, there are some issues with the product itself, that is not easy to roll back the entire bunch of changes. And now let's zoom inside few of the few pieces of advice I might give you to keep in mind when you start to design such architectures. The first of all are the design principles. Probably it's not something new, and I might agree. If you read papers from 80s, from 70s, from 90s, you will find the same principles. There is nothing new added on the spot. However, I think nowadays it's even more harder to fulfill these principles because of the complexity of the software, because of the interactions with other pieces of the code and so on. So in terms of principles, what is important, it's always to pay focus on loose coupling. It's very, very important. And being aware of how to ensure this loose coupling between components, it's a good point. Also composition over inheritance, because inheritance adds by default coupling. Designing messages atomic and services stateless, it's a good recipe. Why? Because you can easily scale. Imagine you want your product to scale horizontally, right? To add more boxes. So being stateless, it's very, very good recipe. And also in terms of APIs, when you design APIs, if those interfaces are coarse-grained, you minimize, for example, the number of round trip times. Implicitly, you can add, make more efficient the requests, you can go towards batching and all other tactics. So keep in mind these coarse-grained APIs. And I might continue with high cohesion. It's important to know how to measure the cohesion inside the module itself, to rely on solid principles, don't repeat yourself, and you don't need it at this stage. So as I was saying, there is nothing new, but today I think it's more difficult to fulfill them in our software. If we zoom inside the architectural styles, first what we had the big monoliths. Probably the monolith, if it has a good structure, like so-called modular monoliths, it's not a necessarily bad architecture. However, it's still a monolith. What are the pros and cons, for example? It's easy to develop on it. However, it's single point of failures. You can't easily scale a monolith, especially if it shares resources like databases. And it suffers all the symptoms that I was talking about. The release cycles are slower, the customer waits a lot until the releases are, the features are released and so on. Then with Java EE especially, Oracle guys, or Sun, promoted this kind of layered architecture. What it says basically to separate the functionality on each layer. For example, we might have the business layer, we might have the presentation layer, we might have the data integration layer, because we needed at that time a better composition for a specific purpose. However, it's still not a good approach in all cases because, for example, imagine you want to develop a feature, you want to cross all layers from the presentation to the integration. How you can scale? You might scale a layer, but it's not so natural or easy. For example, if you want, due to performance, if you want to bypass one layer, what do you think? It's just a dummy request towards a layer, or you just bypass it? So it implicitly can lead to other issues. And then we switch to the service-oriented architectures because we decide, okay, let's even isolate and encapsulate more the services, but put in front of them this enterprise ESB, right? And what happened with the ESB was the ESB was polluted with a lot of logic for routing, transformation, mapping, and all the things. The ESB itself became a monolith. Remember, this kind of architecture style was on fashion like 10 years ago. So we decided to change, and quite recently, not recently, we ended up with microservices. In microservices, we decided to isolate more, we can easily scale, we can put, for example, in front of those microservices a gateway, and all the things around. However, it adds complexity. It's a good pattern to scale your development process. However, if you don't use it consciously, it adds a lot of complexity. And also the orchestration on the services, it's not quite easy to achieve. And we ended up in having serverless. Why? Because, for example, we said that, okay, why shouldn't I use the others infrastructures, a vendor infrastructure, to deploy my component? For example, let's suppose I have a component and I don't care about the infrastructure. Let's deploy in others, for example, in Amazon infrastructure. In this way, for example, from a function as a service perspective, you can easily scale and implicitly add availability, because in this serverless kind of architecture, scalability and availability, it's very easy to achieve. However, it's not the golden hammer because you lock in that vendor. It's not easy to, for example, if you start with a vendor, to switch to another vendor. So you should be carefully about what design decisions you choose when you decide this deployment infrastructure. Okay, so all of this being said,
wait, so we should all go to serverless now. This is what I understood, right?
What do you understood? We should go to serverless because it's quite a good question. Is the serverless the new golden hammer? No. Yeah. So also I would say no. However, if we take care across what had all of this in common, we need to understand the principles. Understanding the principles, we understand the trend. What are the principles that are in common for all? It's a better encapsulation, better isolation, and plus few of them that I will go through them in a few slides. But it doesn't matter the style itself, but the principles are more important, because there is no golden hammer, as I said. So in regards to these principles, first, when you design a component from an architecture perspective, you should know these are so-called early design decisions. In most of the cases, you should understand the protocols. What are the protocols between my component and the outside world? What is the communication type? If the communication type is synchronous or asynchronous, what's the transmission way? If there is one way, two-way, bidirectional, multicast, and so on. Also, on top of that, you need to understand the messages that are exchanged, because, as I was saying previously, you can easily create coupling also via messages. So you should know the type, you should know the format of them, and also you should have in mind at least the dependencies, what you depend on. And also, don't forget to create coarse-grained APIs, because it's always a good recipe. Creating coarse-grained APIs also, it's easier for you to change the implementation behind in time. In terms of internal characteristics for such component, as I was saying, high cohesion, it's a good recipe, loose coupling, better encapsulation from the business perspective. A lot of people confuse this actually encapsulation with getters and setters. It's not about getters and setters, it's about the business itself. From a business perspective, we need a better encapsulation. Also solid principles, the don't repeat yourself or Yagni principles, all of these should be taken into account. Plus, depending on the nature of the project, for example, if you are working on a high-performance field, you should understand if the tasks themselves should be time awareness. What it means, because it adds a lot of important implications. How you bound the execution in one thread, for example. What would be the threading model? What would be my pool size? All of these questions you should have in mind. The scheduling strategies are important. Should I use a round robin or a shortest job first? And also the resource limitation. And here it's a very big exclamation mark. For example, when you are using queues, we are using queues all over the places, but sometimes we forget to limit those queues. So this is very important to try to limit the resources. Plus, if from a data perspective, we should understand what would be the models, how we should model the business entities at the storage level. What would be the access levels? Is it acceptable? Is it suitable to use an ORM framework, or should I use the direct DB connections? When I should use the direct DB connections? Probably for performance, probably because I don't want to add an extra layer in my application. Also, the data for retention preservation in terms of should I use an RDBMS, should I use a non-SQL? We as architects should understand the pros and cons. For example, if we decide to take a non-SQL solution, which one fits better in my product? Because the creators of such non-SQLs, they are very aggressively in advertising, one being better than the other. So we should consciously take the best one that fits on our need. Plus, on top of that, if we can design such features to bind later on, especially during the runtime, it's better because later on adds more flexibility. Later on, for example, you can create mechanisms like hot swap deploy, and without restarting the application, you can easily plug in the new extension. And also you can give the opportunity to the client to design, so you don't care anymore about extensions. However, you should pay careful attention to the frameworks and the programming languages, because these are irreversible decisions, especially the programming language. You can't change it later on. And in terms of frameworks, the one, at least theoretically, one important remark is to keep in mind this clean architecture. Probably is difficult to do in practice. However, what it says that you see in the middle, the yellow circle, and the use cases around it, which means that in your application, the business rules shouldn't rely on the frameworks. For example, the framework, it's included in the outer circle, the DB, it's included in the outer circle. Why is that? Recall the previous slide. It's an irreversible decision. So if you couple your business core logic with a framework, you eventually marry to that framework. So you can't change it later on. And here are some concrete examples how to do that coupling. Imagine you have business rules, the image on the left, and you have a database, right? How can you create a loose coupled way between the business rules and the database? And here it's an example. You can create an interface, and you can create a dedicated implementation for that interface, which it's bind to the DB itself. So from the business rules, you rely on the interface. However, later on, you can change the implementation and easily switch it. The same in case of UI, business rules, and database. The dependencies, at least ideally, I won't say it's wrong if you don't do that, but ideally you should be conscious of this, at least from an architectural perspective. Okay, so having all of this said, let's see. Here is a quiz for you, actually. There are two diagrams out of my software architecture trainings, and I'd like to ask you which one of them you think is an agile architecture. Who wants to answer? Do you want to try, Xavier?
Okay. You know, I'm an agile guy, so I love visual management. So I will vote for the one on the left because there are more colors. And the one on the right is too simple. It's suspicious. What?
Okay, we have none. So you have left. Who's for left? The one with more look and feel. Okay, few people. The one from the right. Who's from the one from the right? More people, actually. So you like simplicity, right? So we have another option, none. Why did you say none? Can you please explain? Okay, so the answer, to repeat, on the right side there is a bottleneck, shared resource on the right diagram, and here on the left one, the one with more look and feel, more colors, probably there is a redundancy across components. My answer with that, if I'd been asked by somebody, I would answer, I don't know exactly. We can't judge, actually. What's the idea? You need to understand first what were the requirements, what were the quality attributes. For which one do you design? Do you design for scalability? Do you design for availability? Do you design for security? Then, having all of them, you go to the tactics. How do you design for that and that and that? And then you challenge with the architecture itself. Only by looking at the picture, I might agree there might not be perfect, there might be redundancy or contention. However, it's not an accurate answer. We need to judge having the context in mind. However, on top of that, the time is very important, because what was good, what was a flexible architecture last year, now can't be anymore the case. So also the time component, it's very important. And the same happens with frameworks, the same happens with libraries that are added in the project. So all of this being said, I'd like to ask Xavier to tell us more about Agile. How come Agiles complement this stuff?
Yeah, okay, so we have just seen how good architectures can enable agility. Thank you, Yadut. Now, how agile principles can help architects in their daily work. First of all, you said that we don't anymore do big design upfront. We do just enough design. Okay, but what is just enough? How do we know when to stop? What is just enough? We cannot know from the start. In the Agile Manifesto, we have customer collaboration over contract negotiation, which means that we regularly ask feedback to the client, to the users, and the users can tell us, oh, yes, it's good, continue. It can tell us, no, that's not what I expected, it's wrong. And they can also tell us, oh, that's good, but stop here, it's good enough for me. You can switch to something more important. So we can apply exactly the same thing with architecture design. As architect, you can regularly ask feedback to your clients, to the developers, basically, and tell them, okay, is it good enough for you to start or not? So what we do in my company is that the architects demo regularly the architecture to the stakeholders, to the team, and when it's good enough, they stop and they do something else. The second thing that you can use from the Agile principles is working software over comprehensive documentation. Our architects, they don't deliver documents, drawings, text, whatever. Our architects code, and they deliver code. They deliver small prototypes of what they have designed. With these prototypes, well, they have something to demo. They have something that can be reused afterwards by the team as templates. They have a kind of documentation of the design itself. So they don't deliver paper, text, whatever. They deliver code, working software. Okay, safe to fail. It is an important part of the Agile mindset to be safe to fail, safe to learn something. Okay. In extreme programming, we are obsessed by test first. Okay, we are obsessed by test-driven development, which, by the way, is a design technique. And you said, Yonut, that the first thing that an architect should do is to elicit the quality attributes. I would say that the second thing that he has to do is to design and implement tests for all of these quality attributes. This is the second thing he has to do. And once he has developed, implemented this test, then this test can drive his incremental design. This test will serve for the demo. This test will serve afterwards as a harness when you have to change your architecture, when you have to evolve your architecture. In the book that we talked about, Building Evolutionary Architectures, these tests are called fitness functions. These are functions that assess the integrity of the system with regards to the architectural requirements that have been elicited. So, an example, you have a requirement of performance. You start first with writing whatever test you need for this, because these fitness functions, these tests, can range from a unit test to a live end-to-end test, right? It really depends on the requirement. So you first write this test, and then it will drive your incremental development. Two other strategies that are useful for this safe-to-fail principle is feature toggles. When you want to introduce a new feature, then you can introduce it, but ask for an activation of this feature and activate it only on some use cases so that you can deploy progressively this feature. And green-blue deployments, in this case, you have a subsystem that you want to upgrade to a new version. You can upgrade only some instances of this subsystem and progressively deploy to the whole zoo of this subsystem. Continuous deployment. Yes, you should also, as architect, use continuous deployment. It consists in automating the fitness functions that we have just talked about earlier and putting them in your pipeline. So we are talking here about continuous deployment and not continuous integration, because some of these tests will clearly be relevant only in a deployment context. You might have some requirement like upgradability, the ability to have hot upgrades, for example. To test this, you are obliged to test this in a real environment. So at the end, your continuous deployment pipeline will contain unit test, integration test, provisioning of an environment, deployment, and other end-to-end tests. So our architects are using a continuous deployment pipeline to deliver incrementally their new architecture design. And the prototypes that they are delivering are tested with this continuous deployment pipeline. Okay, my apologies to the architects here. I pretty sure that you're not like this guy. So I stole this term from Joel Spolsky, astronaut architect. He says, when you go too far up, abstraction-wise, you can run out of oxygen. And you end up with creating this all-encompassing design of the universe, and they are very sexy and very nice, but they don't mean anything for the team, which is on the Earth. Clearly, this is not what we want for an agile team. What we want is alignment and autonomy. We want the architect to be on board with the team. What will this architect do? This architect will own the overall design, will transmit his vision of the design to the team, okay? He will design blueprints, principles, references. He will give technical guidance, and he will regularly review the emerging design, emerging from the team, and ensure that this design keeps consistency with respect to the higher level vision. So here, with this continuous loop of guide, review, adjust, guide, review, adjust, as an architect, if you have the good relays in the team, you will not be an astronaut architect, but you will instead transform the agile team into a team of architects. Okay, that's it. So we have seen how architecture design can help agility. We have seen how agility can help architecture, so we're good, no?
Not quite, I don't think so, because there is just one more thing to share with the audience how we do in practice, actually. And this is the real challenge we face in practice. The thing is that the architecture, it's linked to the internal quality. It's the internal quality of the product, so implicitly it's not on the spot visible to the customer, and that's why the product owner, which basically manages the backlog, tries to deprioritize some sort of task, architectural tasks. How looks our backlog? It contains actually tasks from different categories. So first one, it's about ideas. For example, if in your project somebody else has an idea of an improvement of something that it's new actually, why not add that in the backlog? Give the time for that guy to work on it. Also, it should contain evaluation feedback tasks and technical depth. For example, you can evaluate, you can assess the architecture in the same way you can assess the code. Also, there are some architecturally significant requirements. For example, scalability. If you deal during the next sprint with horizontal scalability, you should create a task and add it in the backlog, and it relies to an architecturally significant requirement. Also, you might have constraints, because we live in a world of constraints, actually. For example, I need to integrate to an external system. This might be a constraint. I need to modularize our project in such way because I go to outsource a part of it. So all of these are related to the constraints, and there should be dedicated tasks for them, plus of course the functionality. So the idea is here, your backlog should be a mixture out of all of these tasks. How we do in practice, probably you might say it's not an ideal rule, but it's a mutual agreement between the architect and the product owner. We establish a quota for the backlog, and the backlog contains around 70% out of the total number of tasks which are linked to the functionalities, and the other 30% architectural and other technical aspects. Of course, it might suffer changes from sprint to sprint. However, relying on this quota rule, at the moment, we know that it is a workaround. We will search for better alternatives, actually, but at least in practice, it works on our environment. So all of this being said, we'd like to thank you for attending the talk.
Thank you.
Yeah, we hope that you got new ideas out of it, and if you have questions, we will be happy to answer.
So did I get it right that you are like an agile team as an architect working with developers on the same task they do, or working ahead, or are you connected to the team somehow, or just giving them some
yes.
stuff?
I'm involved. I'm included in the development team actually. So I work together. I'm part of the same methodology. Everything it's the same. Yeah, there might be cases where architects could share several projects. Now it depends on the complexity of the project, but in our case, the architect it's really embedded in the team. And also, it's a good idea to be like that, because otherwise you will be so-called astronaut architect. So you should be part of the team as any other developer.
Just about this idea of sharing the backlog 70-30%. From my experience, that doesn't work most of the time, because product owners most of the time don't see the value behind handling architectural changes that doesn't give quantifiable value to the product immediately. So my question is, do you see any other rules that can be more effective than this?
Yes, as we said, yes, it's not perfect, and it's the biggest challenge that we are facing right now. The ideal world will be that the product owner understands the benefits of this architecture item versus this functionality, okay? And this is because it doesn't happen yet that we fall back to this workaround. This quota thing, it's a workaround, and it's working for us. But clearly, this is not the ideal stuff. The ideal stuff is having a product owner which is able to prioritize the entire backlog, whether functional or non-functional.
Yeah. I might complement your answer from an architecture perspective, because you asked from another approach. What I'd advise you is to make the product owner aware of the consequences of not prioritizing also the technical things. Talk about consequences, impediments in terms of scalability, performance, availability, and be frank with him. Tell him, if you don't prioritize this, in several months we are going to collapse, we will pay more. This would be another turn of the story. But yeah, that's why we also added this quota role. Okay.
So on a few slides you listed some design principles like coarse-grained API, dry, YAGNI. Do you have any priorities which should be, more important, or it just depends?
No, it actually depends. The principles, that's why they are called such way, they should be by default. However, it might depend, because, for example, if you are working on a real high-performance trading systems, or probably you shouldn't respect all of those. But implicitly, there should be at least at the first sign in your mind as an architect, and you should have tools to measure that from the architecture perspective, because of course you don't know what's the cohesion, you don't know what's the coupling. There are tools that do statistical analysis. But just to get back to the question, there are some principles. You might follow or not. You should be aware of the consequences, I think.
I would like to came back to the architect as a part of the agile team. I would like to know one thing. You said the architect is working with the agile team. So as everyone, he's a developer. So should he really be a full-time developer? Because I don't see the place for the future, for the next futures.
Sure.
Is there any golden rule how to share his time?
I will tell you exactly what I'm doing. It is a very good question because it clarifies. So as an architect, you should code. You don't have time to code as a developer, getting back to the question. So in my experience, I code 20-30%, ideally 30, it's good, because you have other activities like code reviews, architecture reviews, meetings, communication with the stakeholders, but you still need to code, not like a normal developer. You should create, for example, blueprints, but it depends from context to architecture references, guidance, technical leadership. So this takes time, but you should code. For me, it's 30%.
Yes, it's exactly the same in my company. So the architects, they are coding 20% of their time, and they are coding the prototypes. Okay, they are reviewing the emerging design. So this is what they do, and they can do this for several teams. But what they are doing also to adopt this practice of architect in the team, they have relays in each team. So basically in each development team, there is one or two developers, senior developers, who kind of are ramping up on this role of architect at the same time. So it's a way of scaling this architecture design role to the teams. But it's always guide, review, adjust, guide, review, adjust. But yeah.
Yep.
Thank you very much.
I think one more question.
Okay, one more
I
question.
think it's.
On that point, so in the optimal way is that the architect can leave the team because the team itself is able to continue because they are able to have the maturity.
Yep.
So have you done already those transitions, or how?
Okay, so the question is if after a certain stage the architect can leave the team because the product is mature enough and so on, right? Or not the product, the team, it's mature enough. It's risky and it depends. It's risky because without a technical leadership, without somebody to still continue driving for the entire life cycle of that product, especially if it is still under development, the role of the architect could be played, for example, by a technical leader. But still, it's at least from my point of view, it's better to be the architect. And it depends. It's risky. And the second part of my answer, it depends if the product is developed and it can go, for example, in maintenance support. Probably the involvement for the architect is very limited. But however, if the product is continuous development, I won't do that, frankly speaking.
Yeah, on my side, it happened. It happened that in some teams, as I said, the relays that the architect was using, they ramped up and they became more mature, and finally they took on this role of architecture design. So it happened, but yes, it didn't happen a lot, right? It takes time, but yes, it can happen. Thank you very much.
Thank you.